All right, we're going to look at 7.4, where we are asked to simplify radical expressions involving addition and subtraction. So how do we take two radicals and add or subtract them? That's the question. So the answer here is it's just like adding or subtracting like terms. So for example, 5 square roots of 6 plus 7 square roots of 6 equals 12 square roots of 6. You can see since these expressions share the same radical, we add the coefficients in front and keep the same radical. It's just the same as taking 5x plus 7x equal to 12x. So what must be the same about the radicals in order to add, subtract them? They must share the same radical expression. So let's go through the steps of how to do this and then begin to practice. So the very first thing you want to do, if you're ever asked to add or subtract radical expressions, is simplify each radical completely. Then you combine like terms. So for our first one, these are both perfect squares. So this would be 6 minus 10 if you applied the square root to each piece, which would be a negative 4. Now number 2 gets a little bit more complicated because the square root of 48 is not a perfect square, so you can't do that completely here, but we can learn and revisit 7.3 where we simplified radicals. So what we're going to do is, since this is underneath a square root, I want to think about the biggest square that goes into 48, which would be 16. So I get negative 2 square roots of 16 times 3 plus 3. Now I want to think about 75. I want to think, what's the biggest square that goes into 75? Well, 25. So I get 25 times 3. Now what we're going to do is we're going to clean up any number underneath this square root that can. So the square root of 16 is 4. So this part right here becomes 4. Now what you do is you take negative 2 times 4. So you get negative 8 square root of 3 plus, we're going to do the same thing here. Square root of 25 is 5. And then you take 5 times 3, so you get 15 square root of 3. Now you've simplified both of those radicals so that they share the exact same radical expression. Now you can combine the coefficients in front to your final answer. So you get 7 square roots of 3. So let's try again. Square root of 8. What's the biggest square that goes into that? I would say 4. So I get 3 square roots of 4 times 2 minus 6 square roots of 25 times 2 plus 2 square roots of 100 times 2. Now I'm going to clean each one up. So the square root of 4 is 2. 2 times 3 is 6. So I get 6 square roots of 2 minus the square root of 25 is 5. 5 times 6 is 30. Square roots of 2 plus the square root of 100 is 10. 10 times 2 is 20. So I get 20 square roots of 2. Now these radicals all share the same identical radical expression, so I can combine moving left to right. So 6 minus 30 is negative 24. Negative 24 plus 20 is negative 4 square roots of 2. Now when we look at problem 4, we need to simplify a cube root. So I don't want to think about perfect squares. I want to think about cubes. I want to think about a cube number. A cube number, remember, is a number you can achieve from multiplying the same expression 3 times. So here I want to think 8. So I'm going to get the cube root of 8 times 2 plus 4 times the cube root of 27 times 2. So the cube root of 8 is 2, and there's nothing in front to multiply with, so we get 2 cube root of 2. Remember when you're writing a cube root to remember your index. Now here the cube root of 27 is 3, so this piece is 3. 3 times 4 is 12 cube root of 2. Now these share the same identical radical expression, so I can combine the coefficients in front, 14 cube root of 2. So when we go to a fourth root, and that's really the highest root we'll go to clean up radicals, and you really honestly won't see too many of those, we're going to fourth root of 32, you kind of just need to know that that breaks into 16 times 2. Minus 3 fourth root. Now, one way to help me here is I can take the fourth root of 16. So what will be left behind is my 2. So I'm hoping that 2 will be left behind here also so that I have like terms. So I'm going to take 162 divided by 2, and I'm going to get 81. And I get 81 times 2. Now it just so happens that 81 is 3 to the fourth power, so I can apply the fourth root to this number. So the fourth root of 16 is 2. 2 is going to be multiplied with negative 5 for negative 10, and I get the fourth root of 2. Minus the fourth root of 81 is 3. 3 is going to be multiplied with 3, so I get 9 fourth root of 2. These are carrying the same sign, so I'm going to add and get negative 19 fourth root of 2. All right, now let's add in some variables to our simplifying work. So here, 72, what's the biggest square that goes into this? So I'm going to say 3 square roots of 36 times 2m squared minus 5 square roots of 16 times 2m squared minus 3 square roots of 9 times 2m squared. Remember, a helpful hint here is if 2 is what's left behind in the first one, I divide here by 2 to get 16, and I divide here by 2 to get 9. Now I'm going to go clean all of these radicals up. So the square root of 36 is 6. 6 is multiplied with 3 for 18. Now the square root of m squared also can't stay, because remember, you can't have an inside power that's the same or larger than the index. So 2 goes into this 2 one time, so I get an m. So the only part that's left behind is the 2. Now I'm going to go again. The square root of 16 is 4. 4 times 5 is 20. The m squared comes out as m, and I'm left with the square root of 2. Minus one more time, square root of 9 is 3. 3 times 3 is 9. Square root of m squared is m. Square root of 2. Now notice across all of these they are like terms because they all have an m and they all have a square root of 2. So I'm going to combine all of these together. 18 minus 20 is negative 2. Negative 2 and negative 9 is negative 11 m square root of 2. And that would be my simplified answer. 27 is a cube root, and the cube root of 27 I can already do. The cube root of 27 is 3. 3 times 2 is 6. And x stays behind because it is x to the first power and 1 is smaller than 3, so I can't do anything with it. Minus cube root of 8 is 2, so 2 times 2 is 4, cube root of x. These are matching radicals, so I can finish my subtraction and get 2 cube roots of x. So now we're going to look at some that involve fractions. So what I'm going to do is I'm going to use the quotient rule, which says I can apply the square root symbol to both the numerator and denominator. So I'm going to write the square root of each piece. The bottoms are very easy to figure. This would be 3, and this would be 6. The top I have to again think about what's the largest square that goes into 8. So I would say this is 4 times 2. And this is 9 times 2. So then I'm going to clean this up, and I'm going to get 2 square roots of 2 over 3 plus 3 square roots of 2 over 6. Now these fractions are like terms because they both have a square root of 2. But to add fractions, I must have an LCD, which is 6. So this is going to become a 6. That's by way of 2, so this would become 4 square roots of 2 plus 3 square roots of 2 over 6, which will end up 7 square roots of 2 over 6. To do 9, square root of 8 is just like this square root of 8. It's the square root of 4 times 2 minus, this is already a perfect square. All right, so that's 8 over 4. So this becomes 2 square roots of 2 minus 8 over 4 is 2. Now I can't go any further, and I cannot do any subtraction because this term does not have a square root of 2 with it. So these are not like terms. So I'm finished with problem 9. Now problem 10. First, I need to simplify these radicals, so I get cube root of 8 is 2. 2 times 2 is 4. This power is larger than my index, so remember I divide. 3 goes into 4 once, so I get an x out, and I'm left with an x inside. Be careful to remember to write your index. Plus the fourth root of 16 is 2. 2 times 3 is 6. 5 is bigger than 4, so I have to divide here. So 5 divided by 4 is 1. So an x comes out, and I have the fourth root of x inside. Now, these cannot be added together because these radicals are not identical. One is a cube root and one is a fourth root. So I can simplify them, but I cannot add them. Problem 11, we're going to apply the cube root to each of these pieces. If it helps, 3 is over 1 and 2m is over 1. So I get 3, and then I'm going to take the cube root into m to the 5th. So 5 divided by 3 is m, and I have a remainder of 2, so I have m squared left inside. The cube root of 27 is 3 minus, let's do the other one, 2m. Cube root of m squared I can't do anything with because the inside power is smaller than the outside index. Cube root of 64 is 4. Now, I need to make a common denominator because the numerators are like terms. I have an m and a cube root of m squared for both, but I need an LCD to continue, which would be 12. So to get to 12, this would be by 4, so this is 12m cube root of m squared minus, this is also needing to be 12, that's by 3, so this is 6m cube root of m squared. So now I can subtract 6 from 12 and get 6m cube root of m squared over 12. And then one more thing, 6/12 reduces, so I need to finish reducing this down to 2. So I get m cube root of m squared over 2 as my final answer. A couple more here just to finish. So this one, I'm going to apply the square root to each piece of this fraction, so I get 5 over x to the 4th. I get 4 because 2 goes into 8 4 times. Minus 3 over x to the 3rd because 2 goes into 6 3 times. Remember, we're getting 2 because this is square root and our index is 2. Now I need an LCD. So if this is x to the 4th, I need this to become x to the 4th. So I'm going to multiply both by x. So I get 5 minus 3x over x to the 4th, which is as far as I can go on that problem. I can't take 3x away from 5. Problem 13, I'm going to clean all 4 of these up. So first I'm going to think about what squares go into these numbers. So this I'm going to say 4 times 3m to the 3rd minus the square root of 4 times 2m to the 4th plus 16 times 3m to the 3rd plus the square root of 9 times 2m to the 4th. Then I'm going to clean each one of them up. So the square root of 4 is 2. M cubed has a bigger power than index, so 2 goes into 3 once, so I get an m. And what's left behind is the square root of 3m. Minus here, I get square root of 4 is 2. 4 is bigger than the index. 2 goes into 4 twice, so I get an m squared, and all I'm left with is the square root of 2. The third one, square root of 16, is 4. Same idea with this m cubed. 2 goes into 3 once, and so I'm left with the square root of 3m. Plus last one, 3m squared, square root of 2. Now notice, they don't all match, but this one matches this one, and this one matches this one. So I can pair them up to finish combining like terms. So 2m square root of 3m plus 4m square root of 3m would be 6m square root of 3m. Remember, you just add the coefficients in front. Negative 2m squared, square root of 2, plus 3m squared, square root of 2 would be plus m squared, square root of 2. To do 14, all we have here are variables with powers, so we're going to divide the powers by 4. 4 goes into 9 twice, so I get 2m squared. I'm going to give myself a little room because I have the p to also deal with. But 2 goes into 9 twice to get to 8, but I have a remainder of 1, so there's an m left behind. 4 goes into 6 once with a remainder of 2, so I get a p squared also left behind. The middle one is actually doesn't need any simplifying. 3m squared p, 4th root of mp squared. The reason why there's no simplifying work is because all these powers are smaller than 4. This one, 4th root of 16 is 2. 2 times 5 is 10. The m is to the first power, which is smaller than 4, so there's nothing to do there. 4 goes into 6 one time, so along with this m squared, I also have a p. And what's left inside is this m, and the p squared, which is the remainder when 4 goes into 6. Now, if we look across, all of these are now like terms, so we can combine. 2 minus 3 is negative 1. Negative 1 plus 10 is 9m squared p, 4th root of m p squared. All right, last one. It says find the perimeter of the triangle. Well, we find perimeter by adding all the sides. So we take 3 square roots of 20 plus 2 square roots of 45 plus the square root of 75. That's how we find perimeter. We add all the way around the sides. Now we can't add these radicals together until we clean up and simplify each radical. So again, every time I see a square root, I want to think about my square list and figure out what's the biggest square that goes into 20. So I get 3 square roots of 4 times 5, plus here this would be 9, so 2 square roots of 9 times 5, plus this is 25 times 3. So this one would be square root of 4 is 2. 2 times 3 is 6. So I get 6 square roots of 5 plus square root of 9 is 3. 3 times 2 is 6. Square root of 5 plus square root of 25 is 5. Square root of 3. Now I can't add all of these together because square root of 3 is not the same radical as square root of 5, but these I could add together. So I get 12 square roots of 5 plus 5 square roots of 3. Remember, we're finding perimeter, so we need to label this with inches.